In this video, we're going to talk about how we can use JASP to conduct descriptive statistics. And so, what we want to do is we're going to use the same data set that we've been using all week, which is on the the active child care providers in the state of South Carolina. And so, what I'm going to do is I'm going to open the data set where I've saved it on my computer. I go to browse, I have week 2, and I'm going to open up the CSV file. And as you can see, I have that data set that is listed from that file. And so if I want to go in and conduct descriptive statistics, whether I want to do a graph or I want to calculate values, I'm going to go here to descriptive statistics. And within that, once you click on that, that will open up this menu where we're going to see all of the results of our descriptive analysis. And so I'm going to start with a categorical variable or qualitative variable, which was permit type. And I'm going to put that into this data set here, or into this box that says variables. And what appeared in our section that says descriptive statistics is our sample size, which is valid, is given in that row of that table. And then we're told that there are no missing values. Now, JASP has the ability to recognize that this is not a quantitative variable. So it knows not to give a mean or a standard deviation, a minimum or a maximum value. However, it does allow us to still do statistical analysis. For instance, if we wanted to get a frequency table, if I go here to tables, I believe, and I click on frequency table, now I will see the frequency of each of the observations within my data set. So for instance, I know that there are 215 approvals, 1340 license, childcare centers, so on and so forth. The only difference is that JASP allows us to see whether we had any missing values. Now, in our lecture, we saw that we had the relative frequency. Well, JASP just gives the percentage, and it also gives a valid percentage, basically based off of the non-missing information. And then it gives us the cumulative percentage. So remember when we were talking about cumulative frequency distribution, and when we were talking about the percentiles in that SAT score example, that just means that I'm going to take the percentage in this category, or whatever category I'm on, and add up the percentages of all of the previous categories in the upper rows of the table than where I currently am. So that is our frequency distribution. That's in the tables part. And if I go here to basic plots, I can get a distribution plot, for instance. I'm going to click on that and see if anything pops up. Of course it does. And the one thing that I don't like necessarily about JASP is that sometimes it makes the words overlap. But if you hover over the actual graph and look at that bottom right column, you can resize your plot so that your words won't overlap with each other. And you can make them taller, so on and so forth, to adjust your plots. And so here we see our bar graph. The statistical software that they're using to create this, I believe, is R. And it does have some SPSS type output as well. And so if you're familiar with either of those, then sometimes you can, if I'm not mistaken, also adjust your plots to that. I'm going to click here to Pareto plots here. Here we see our same type of scenario with our graph. But notice with Pareto charts, we're going to see our bars in our bar graph ordered in descending order. which is a little easier to read. Notice in this one, they also give you the percentages of each of the categories as a second vertical axis that's given to the right. And so that is some stuff with some of our categorical data analysis for those ordinal or those nominal variables. Now I'm going to start over. So I'm going to click on permit type, and I'm going to use this arrow here to remove it from my analysis. And now I'm going to use my quantitative variable capacity and put it here. Notice when I did that, I was able to see my sample size on the row that says valid. That means I have observations on this variable for that number of individuals. I have a missing, that means 84 child care centers. I did not have a capacity in my data set. And then JASP has the knowledge or the capability to recognize that all of the values of that variable are numerical, as most of them are in that column, or all of them are in that column except for the missing. But it gives me my summary statistics, which are mean, standard deviation, minimum, and maximum. All right, so that's an initial. Notice with this frequency table, JASP actually has a rule that it'll create frequency tables whether your variable is quantitative or qualitative. But if there's more than 10 distinct values, it is not going to create a frequency table because you should use a graph. Remember in that lecture, I said something around 12. JASP is even more strict, that is saying, I'm not making a frequency table if there's more than 10 values. And so we definitely should be using a graph instead of a frequency table. Now I'm going to go to the tables here and clear this off since we're not going to be using the frequency table. But notice also under this tables menu, there are stem and leaf plots that you can create. Let's not do that for this large data set because there's over 2,000 observations. Now, there are some other plots. So here I'm going to go to box plot, basic plots. I'm going to unclick that. And notice here, I'm going to go to distribution plot. And now I can get my histogram. Notice I can see, we saw this in our example in our lecture. This is another table or graph that we have. Notice that this is a positively skewed data set, right? We have a long tail to the right. And so these descriptive statistics here, while they're calculated, remember when we have a skewed data set, we want to use the 5-number summary as our summary statistics. And so I'm going to leave this histogram here, but I'm going to make an adjustment to my descriptive statistics. And so I'm going to go to this menu here. Remember with your descriptive statistics in your 5-number summary, you want your quartiles. Well, your quartiles are in your quantiles section. We also want our median instead of our mean. We're going to talk about some of this later. We want our maximum and our minimum value, and we don't necessarily need our standard deviation, right? And so I unchecked or checked whatever we had, and now I have my descriptive statistics here. What's nice is that they give it to us in a nice table that we can copy and paste and make adjustments to be to conform with APA. If we want it to report in a table. But here we are. We have our 5-number summary as well as our sample size and any missing information data that we have. And so we can see that our min capacity is 5. Our 25th percentile or quartile 1 is 6. Our median is 60. Our quartile 3 is 130.5. And our maximum is 622. All right. One thing that I also want to show you is that we can also, since we have our 5-number summary, we can create a box plot. And so I'm going to go to customizable plots here, and I'm going to click on box plot. And what JASP is going to do is it's going to create a box plot. So there were some things that I did not get to explain in our lecture, and this box plot here is perfect for doing that for us. Remember I said that this is a box and whiskers plot, right? And below the box, there's a whisker. Well, if I look at this graph here, and I'm going to make it bigger, We don't see the bottom whisker, but if you look very closely, I'm going to try to extend this a lot more. You can see where the whisker kind of aligns with the first quartile, right? Remember, our minimum value was 5 and our quartile 1 was 6. And so since our scale has such large numbers, it looks like our minimum and our maximum are at the same value. They're not at the same value, but graphically they look that way. But then I have my first quartile, my median, my third quartile. And from my third quartile up to 300 and something, I have the end of my whisker. But in our lecture, we said, oh, the whisker is going to extend to your maximum value. All right, that is going to be the case unless we have what we call outliers. This graph here shows a very, very skewed distribution. Most of our data is over here, and we have very few observations that are very far away from our main number of observations. When that occurs, we obtain what we call outliers. And outliers are very, very extreme values that's on the tail ends of our distributions. Well, the default here in JASP is to plot your outliers with a point above your whiskers or beyond your whiskers. And so basically, JASP has identified a lot of observations as outliers. And so our whisker is going to stop at the last point that it would not consider an outlier. That is why it extends here to 300 and something instead of going all the way up to 622. One of the nice things about these box plots is the ability to identify these outliers when you have these skewed distributions. You can label the outliers, but they're not going to be all that helpful. Notice here in this box, if you hover over this box that says label outliers, I'm going to change this. It tells you how they're calculating the outliers. It's taking 1.5 and multiplying it by the IQR. And if an observation is beyond that, above or below the first and third quartiles, it's going to identify those as outliers. That's a pretty standard way of identifying outliers. But I wanted to point that out. So that is the box plot feature. We can see the right skew. Notice here that our right side of our graph, and since this is vertical, it's going to be the top part of our graph, is extended way longer than the bottom part of our graph, which doesn't have an extension at all. That's evidence that we have a distribution that's skewed to the right. If most of our distribution was above and we had a longer whisker below, we would say that it's left skewed or negatively skewed. All right, the last thing I want to talk about in this video and to show some of the capabilities of JASP is this split box here. Whenever we have multiple, if we wanted to look at a comparison of a quantitative variable across different levels of a categorical variable, we can just use the split here to achieve that. For instance, if I wanted to compare the capacity, which is a quantitative variable, across the different permit types for child care centers, then I can go over here to permit type and put it in that split box. And then what JASP is going to do is it's going to recalculate all of my descriptive statistics separately for each of the values of that permit type variable. So, for instance, for child care centers whose license or permit type equals approval, they have a minimum capacity of 16, maximum capacity of 520, and these are their quartiles. You get the same for your licensed child care centers, and you get the same for your registration, those that have a registration, right? Notice here that those that are not licensed, that permit type for not licensed, they're considered exempt, so they don't have to be licensed. They all had missing values for the capacity variable. And that's because the state doesn't, since they're not licensed, the state doesn't collect that data in a public way for those child care centers. So all of the capacity for those centers are missing, and we have 0 valid data points, or a sample size of 0 for that capacity variable. So that means we can only compare the capacity for these other 3 categories of the permit variable. When I did that, if I go to these distribution plots, it's going to give me one separately for each of those variables. So I get a histogram for the approval, histogram for the license. I don't have any information for the not licensed or exempt. And then we get those for the registration. All right. In addition to that, the box plots are nice because we get a separate box plot for each of these. And these are called side-by-side box plots, right? So we can see that, okay, well, if I look at the middle 50%, because these are some skewed distributions, the middle 50% for the approvals are a little bit higher, or they cover some higher ranges more often than they do for license. So our approved childcare centers tend to have more of a higher capacity as compared to our licensed childcare centers. And notice here, it looks as though for registered childcare centers, we don't necessarily have a box. That's because it looks that way. It can be a little misleading, but it looks that way because if I go back up to our descriptive statistics, our minimum is 5, our maximum is 575, but our first, second, and third quartiles are all 6. Now, I'm going to tell you a little bit about this just because I worked with this data since I worked with childcare here in South Carolina. The vast majority of our registered childcare centers are registered centers. A lot of them are family childcare homes. There's a lot of them that are registered. They can be either registered or licensed. Most of the normal childcare centers that are in childcare facilities, most of them are licensed, although some of them may be registered. So that's why you see some with large capacities. And any faith-based childcare center is in this registration permit type. And so that's why we see these here. But we don't see the box because the over 75% of those that are registered are family childcare homes, and their max capacity is 6. So this one looks a little weird. But we've gathered all of that information just by looking at these numerical statistics as well as these graphs. And so you can create other types of graphs, get other types of statistics by going to this descriptives section of JASP. And so I'm going to stop here, and I recommend that you definitely take some time to play with JASP, not only with this data set, but play with the other data set that I'll be placing online for you to do as well.